Hello and welcome to one of our reviews today. So today we're going to work on reviewing for chapter 4. It may or may not be part of your test for your class, but these are the problems that I'm going to work on. It's the review for chapter 4, but it's actually the book test beginning on page 403. It says chapter 4 test, and we're going to work on problems 1 through 14. So this is what it says. We're using this as our review. I have a Desmos link to go with it because I always encourage you to put in your equations into Desmos. It's asking you to solve the following systems by the addition method. Now, on my particular test, you can use whatever method you would choose, but this is set up to use the addition method because I can either get to a multiple of x or a multiple of y so that they add to 0 and we eliminate one of the variables. So the addition method is also called the elimination method. So I have put these two into Desmos, and let's just go there so that we can see what Desmos says we should have. So there it is, 2x minus 5y equals -8, 3x plus y equals 5. So I'm going to turn them on, and then we are going to click on one of them. And when you do, the intersection comes up. So our intersection should be at 1, 2. So on my paper, and I'm asking you to do this on, if you're in my class, on the exam, and we're going to go back to the paper and we're going to work this out by hand. So the answer should be 1, 2. Now I probably won't show you all my Desmos. All of these are in Desmos. I probably won't go back and forth between them today, but I will tell you what the answer should be so that we know what we're working towards. So you should be able to put that into Desmos to know that up front. Okay, so we can either get to a multiple of x. So we could either use 6 for x, because 2 times 3 is 6. Or we could use 5 for y. Now, I'm going to choose to use 5 for y because row 1 is already at a multiple of 5. Row 2 is at a 1 for 5, and they're already at opposite signs. So that gives me a bonus. So I'm going to leave row 1. So 2x minus 5y equals a -8. And so I'm going to multiply row 2 by 5. Now, make sure you multiply every term in row 2 by 5. So we get 10x minus 20 minus, sorry, we're multiplying row 2. So this is 15x plus 5y equals 25. So 5 times 3 is 15x plus 5y equals 25. So when we add these, we do eliminate the y. I'm just going to write what we did, eliminate y. And when we add these, we get 17x equals a -8 plus 25 equals 17. And so when we divide by 17, we get x equals 1. And so then we can double check. We know that x does equal 1 because that's what we found in Desmos. So then I'm going to put x equals 1 into either row 1 or row 2 and to solve for y. Okay, so I'm going to do row 1. So 2 times 1 minus 5y equals a -8. So 2 minus 5y equals a -8. Remember, I'm solving for y, so I have to undo everything that is attached to y and undo the adding and subtracting. I have to undo this constant first. So we're left with a -5y equals a -10. And then we're going to divide by a -5. So y equals a -10 divided by a negative. That makes a +2. And that is what we wanted. So we did get 1 and 2. Question 2, if you go to Desmos, you will be able to see that the solutions should be 3, 2. Now, this again is set up for addition because my x's are lined up and my y's are lined up. And I'm going to just use common multiples. So for x could be 4 times a negative 5 or 4 times 5. So we could get them both to 20, or y could be 7 times 6, and we could get those both to 42. It's up to you. I'm going to eliminate x. So that means I have to multiply by the opposite. So I have 4x, so I'm going to multiply by, and they're already opposite signs, so we don't have to worry about that. So 5 times row 1 will give me 20x minus 35y equals a negative 10. And then I'm going to multiply 4 times row 2. So a negative 20x plus 24y equals a negative 12. And when I add them, I did eliminate x. So a negative 35 plus 24 is a negative 11 equals a negative 22. Well, it's a negative 11y. So we have to divide by a negative 11 because it is what's attached to x. And so we get y equals 2. And that matches what we should get. So I'm going to put y equals 2 into row 1. I'm just choosing it just to be easy. So 4x minus 7 times 2 equals a negative 2. 4x minus 14 equals a negative 2. And then I have to add 14 to both sides. 4x equals 12. Because we're solving for x, we're going to divide by 4, and x equals 3. And that also matches what Desmos told us was the correct answer. Question number 3. This is also in Desmos, so you can check. Go to Desmos, type it in, make sure that you write down what your answer should be. So my two equations are 1/3 x minus 1/6 y equals 3. I'm just going to write my answer up here. In Desmos says it should be 15, 12. And then the other equation is negative 1/5 x plus 1/4 y equals 0. Okay. I personally do not like working with fractions. So the first thing that I'm going to do is go back to what we did in chapter 1 where we eliminated the fractions. And so to do that, I'm going to multiply row 1 by my least common denominator, which is going to be 6. Because I can, so if I do 6 times row 1, I get 6 times 1/3 x minus 6 times 1/6 y equals 6 times 3. So I get 6 over 3 is 2x, and then my 6 is canceled there, and we're left with y equals 18. So that's going to be my new row 1 down here. 2x minus y equals 18. Now I'm going to eliminate my fractions in row 2. And so my LCD is just going to be 5 times 4. So I'm going to multiply through by 20. So 20 times row 2. So 20 times a negative 1/5 x plus 20 times 1/4 y equals 0 times 20. So 20 times a negative 1/5 becomes a negative 4x plus 20 times 1/4 is a 5y equals 0 times 20 is still 0. So row 2 is really a negative 4x plus 5y equals 0. So eliminating your fractions makes it much easier from the beginning. Okay. Now I can see that I have opposite signs on my x's, so I could multiply row 1 by 2 to get a positive 4, and then I would have a negative 4 already in row 2, and they would add to 0. So I'm going to do 2 times row 1 right below here. So that's going to be 4x minus 2y equals 36. And then I'm going to add these two here because I modified row 1. So my x's eliminate. I'm left with 3y equals 36. And when we divide by 3, we get y equals 12, which is what we had. You can see that. And then we can put 12 back into, I'm just going to put 12 into my modified row 1, just because I know what my answer should be. X should be 15s, and it's just easier to work with the one without, that doesn't have fractions. So 2x minus y, which is 12, equals 18. And when we add 12 to both sides, we get 2x equals 30 divided by 2. Indeed, x does equal 15. So our solution of 15, 12 is correct. Now, each of those problems was using the addition substitution method. And like I said, it depends on your teacher on what they expect as far as on the exam. Do you have to use one method over the other? So you can see problems 4 and 5 are saying solve the system by using the substitution method. And I choose to use the method that's actually set up easiest for me. And the reason why this one is easier for the substitution is because you have a clear recipe for just y, not 2 times y or negative y, but just y. So you can take this recipe for y and substitute it into row 1 and solve for x. Okay, so Desmos tells me that my answer should be a negative 54 over 13 and a negative 58 over 13. You can see this, that's in fraction form. So let's just go so you can see how you would do this in Desmos. I'm going to turn off the ones that I was using, and this is question number 4. So we're going to go down to 4 and turn on those graphs. And then we're going to scroll to where they intersect. And you can see that the intersection is oops, let me get away from it. It is a negative 4.1. I'm going to write it on my paper in the decimal form too. Negative 4.154, comma, negative 4.462. Okay, so in Desmos, I'm just going to put in negative 4.154, and then I'm going to put it in fraction form and see if it comes out to be what we had. So now that is not quite the fraction answer. And so either of these would work. It's just you're going just by what Desmos is giving you. So that negative 4.154 is a rounded decimal, and that's why. Okay, so let's go back to our paper here. So I'm going to take my recipe for y and put it into row 1. Take my recipe for y into row 1 and solve for x. Okay. So 2 times x minus 5. And now that I see a y, I'm going to put my recipe for y, which is 3x plus 8 equals 14. So you should have an equation all in x's. If you don't, then it's not getting you to where you want to be. So now we have to distribute the -5, all of that -5 to both terms on the inside. So this is 2x minus 15x minus 40 equals 14. When I distribute the -5, it's a multiplication that I'm distributing. Now 2x minus 15x is a -13x. Subtracting 40 equals 14. I'm solving for x. I'm going to circle that. Adding 40 to both sides, we get a -13x equals 54. And dividing by a -13, we get a -54 over 13, which is what we have up here. So that worked out. Okay, so I'm going to put that to solve for y. So y equals 3 times whatever x is, which is a -54 over 13 plus 8. So that becomes a -162 over 13 plus 8. And 8 over 1 with a common denominator of 13 is 104. So this comes out to be a -58 over 13, which is what we have. Oh, that should be a negative. Equals oh, my answer from Desmos should have been negative and negative. So yep, a negative and negative. We got it. Okay, moving on. Number 5. This is getting you ready, and I'll sharpen that for the exam. So number 5 in the book is asking you to solve using substitution. 6x minus 3y equals 0. X plus 2y equals 5. Now you could use the addition method. It's kind of set up for the addition method, but we're going to practice using substitution. Putting this into Desmos, we know our solution should be 1, 2 over here in the top right. So to use substitution, I have to have a complete recipe for either x or y. Well, it's really nice to be able to solve for x because it only has a 1 coefficient anyway. So if we subtract 2y, we can make a recipe for x using 5 minus 2y. So we can put this into row 1, and then you're going to solve for the opposite variable x. So 6, and since x is 5 minus 2y, and then minus 3y equals 0. We should have an equation all in y's. Oh, we're solving for y. Sorry about that. We're solving for y. I'm going to distribute my 6. So we get 30 minus 12y minus 3y equals 0. Combining like terms, we get 30 minus 15y equals 0. And we're solving for y. So I'm going to move everything else to the other side by subtracting 30. We're left with a -15y equals a -30. Be careful with your negatives because it's easy to get those lost somewhere. So a -30 divided by a -15 gives us a +2 for y, and that's what we wanted. And then we know that x equals 5 minus 2y. And I will be right back. Okay, so now we're going to put y equals 2. So 5 minus 2 times 2. So x equals 5 minus 4. So x equals 1. And indeed, x does equal 1. Okay. Now, problem 6, 7, and 8 are all solving for the triples. So 6 is 2x minus y plus z equals 9. Let's make sure you get these all written down correctly. Okay. So when we have the triples, we have to make sure that we are actually creating 2 new rows. So we're going to eliminate one variable and create 2 new rows. Now, before we do that, let's just go to Desmos and check out what our answer should be. So these are a little bit different because there's 3 of them. So let's go down here. This is number 6. So I'm turning on number 6. And so you can see in the picture that the 3 lines are not meeting right now. So we're going to go to the slider. It should automatically create a slider for Z when you type these in. So when we move the slider to the left, it looks like they're getting further apart. So if I move it to the right, I'm moving, oops, they went past each other. So I'm moving it so, oops, so they equal each other's. Oh, it looks like there. So when Z equals 1. So now when Z equals 1 on the slider, I can click on the equation. And it doesn't look like they're at. There it is. More than likely, they're going to be integers. So X and Y should be 3 and a negative 2. So it should be 3 and negative 2, and Z is 1. So I'm going to take you to my paper so you can see how I would write that. So 3, negative 2, and 1. So we need to create Y row 4. So I'm going to add row 1 and row 2 because Y eliminates. So my row 4 is going to be 3x minus 2z equals 7 because the y's can eliminate. And then my row 5, I'm gonna add row 1 and row 3 here. So I'm gonna add row 1 and row 3. So when I do that, I get 5x. The y's eliminate, oh, and the z's eliminate. So I'm just gonna put plus 0z equals 15. So the cool thing with this is because Z got eliminated, I essentially don't have to go any further as far as row 4 and row 5. I can just solve for X here. Because this is 5x equals 15, I can divide by 5 and find out that X equals 3, which matches Desmos. And then I can go into row 4 because row 4 is just in 2 variables. So I can use X equal to 3. So 3 times 3 minus 2z equals 7. Now I can solve for z. That worked out well for us. So 9 minus 2z equals 7. If I subtract 9 from both sides, I get a negative 2z equals a negative 2. And dividing, I get z equals 1, which does match z equals 1. So now I can go back into row 1 to find X, or to find Y. That's the only one we don't know yet. So 2 times X is 3 minus Y plus Z is 1 equals 9. So 6 minus Y plus 1 equals 9. And so we have 7 minus Y equals 9. And we're trying to solve for Y, so we're going to subtract 7. We get a minus Y equals 2. And we don't want to know what a negative Y equals. We want to know what a positive Y equals. So we have to divide by a negative. So Y equals a negative 2. So we did verify X equals 3, Y is a negative 2, and Z is 1. Okay. So number 7 is the next one. Two x plus 4y equals 3, and negative 4x minus 8y equals a negative 6. So this is back to solving the system, but it's only in 2 variables, so that's nice. And it looks like when you put it into Desmos, they are the same line. So that must mean that they are multiple of each other. So if we took and tried to eliminate x, we could get them x to be 4. So 2 times row 1 would be 4x plus 8y equals 6. And you can see that row 2 is already a negative 4x minus 8y equals negative 6. And when we add them, we get 0x plus 0y equals 0, which is true. So when you get a true statement, they are dependent lines. So all solutions work. Okay. Let's look at number 8. Number 8 is 2x minus y plus 3z equals 2. X minus 4y minus z equals 6. 3x minus 2y plus z equals 4. So we have to create a row 4 and row 5 by eliminating one of the variables. It looks to me like z might be the easiest because we can get, so row 2 and row 3, these two add to 0 automatically. So I'm going to make that row 5 just by adding them right now. So we get 4x minus 6y equals 10. And then I'm going to do a multiple of, I'm going to do row 1. As 2x minus y plus 3z equals 2. And I'm going to get row 2 to be a 3 because it's already an opposite sign. So I'm going to do 3 times row 2 is 3x minus 12y minus 3z equals 18. And we're going to get row 4 from that. So that will give us 5x minus 13y, the z's cancel, equals 20. Okay. Now from row 4 and row 5, we have to get them to cancel. And so I'm going to eliminate x by getting it to 20 because they're both 5 and 4. So we can do 5 times 4 to get to 20. So I'm going to make the top one the positive. So I'm going to do 4 times row 4. So we get 20x minus 52y equals 80. And then I'm going to have to make the second one negative. So a negative 5 row 5. So that'll be a negative 20x plus 30y equals a negative 50. So the x's cancel and we're left with a negative 22y equals 30. And so y equals a negative 30 divided by 22. Now, we forgot to put this in Desmos. So let's reduce that. So that becomes, divide them both by 2, and negative 15 over 11. Okay. So in Desmos, it does say that the solution is 5/11, a negative 15/11, and a negative 1/11. And I did that because I forgot to do it at the beginning. So it should be this. So let's go to Desmos and just so we can check, because the ones with the triplets are a little bit trickier. I'm going to turn off those. I'm still going to need my slider, but it's down here. So I'm turning on my 3 equations. You can see they don't equal. I'm going up to my slider and I'm grabbing my slider. If I go left, it looks like they're getting further apart onto the right. Let's see, where are they crossing to the left? Oh, that looks like it's close. So it looks like when z is a negative 0.1, let's look at these other ones. We get 0.48 and a negative 1.433. And then a negative, well, z is a negative 1/10. So I'm just going to go down below my equations. And I'm going to put in the fractions that I have. 0.48. I'm going to go up and put that in Desmos here and just see what is that in the fraction form. 12 over 25. So that's close to the fraction I have. And then what is 1 divided by 11? So that's close to 1/10. Okay, so we're close. They just have to be reasonably close. And so when we get our fractions by hand, it should work out. So let's go back to my paper here and work these out. Okay, so we got that one. Okay. And so we can put that back into row 4, let's say. So row 4. So we know 5x minus 13 and y is a negative 15/11 equals 20. So 5x, a negative times a negative is a positive. And let's multiply in Desmos 13 times 15 over 11. So 13 times 15 over 11. Okay, so we get a decimal 17.72. Let's see if that is an even fraction. Okay, it is. Let's use it. It's 195 over 11. 195 over 11 equals 20. Okay. So I'm going back to my, no, I don't need that thing. Okay, so I'm going back to my paper. So you can see here what we have. Okay, so we have 5x. I'm trying to solve for x plus at 195/11. So we're going to take 5x. We're going to subtract 20 minus 195/11 from both sides. Okay, so 20 minus 195/11. So let's go back to Desmos so that you can see my work because these are tricky. So 20 minus, no, 20 minus, and then in parentheses, 195/11. Okay, and we get, and let's just see if that's an even fraction. Okay, it is 25/11. We'll take it. So we have 5x equals 25/11. And then we're going to divide both sides by 5. So we're going to take 25/11. So I'm going to type it down here. And I'm going to say 25/11. And I'm going to put that in parentheses. Up here, 25/11, and I'm going to divide that again. So it's a fraction divided by a fraction. Oops. 25/11 divided by 5. Okay, comes out to be 0.4545. Let's see if that's an even fraction. It is 5/11. Yay. And that is what our Desmos said. So I'm going to take it back to my paper so we can all agree on everything. Okay, and so now we need to find z. So I'm going to go into I'm going to use row 2 just because it looks like the simplest one to use. Row 2 to find z. So x we think is 5/11 minus 4 and y is a negative 15/11 minus z equals 6. So 5/11 and negative times a negative is a positive 20/11 minus z equals 6. So now we have 25/11 subtracting z equals 6. Okay. So I'm going to subtract 25/11 from both sides. So we still have a negative z. So 6 minus 25/11. Getting the common denominator will be 66/11 minus 25/11. Because it's 6/1. So a negative z equals 66 minus 25 is 41. 41/11. X minus 4y positive. Oh, and so subtracting. That does not make sense because that doesn't get us to the negative 1/11. So let me pause this for a moment. On my mistake right here. I don't know why I put 20 here. So when we multiply the negative 4 times the negative 15 is a positive 60/11. So that would be 65/11. So we're subtracting 65/11. We're subtracting 65/11. Subtracting 65/11. Subtracting 65/11. And so we're left with a positive 1/11. But we don't want a negative z, we want a positive z, so we have to divide by a negative, and we end up with z is a negative 1/11, which is what we thought. Woo! Number 8 was a toughie. Okay, so now catch me back. Let's pause for a moment. We're going to look at 9 through 14. The goal on each of these is to write out the 2 equations and then solve using any strategy that you'd like. So number 9 says, a number is 1 less than twice another. Their sum is 14. Find the 2 numbers. So I always look to see if they tell me something just about the 2 numbers basic, and they did. They said the sum is 14. So we know that x and y add because sum means add. So they add to make 14. So that's one equation. That's good. And then a number, so we can say x is equal to 1 less than something else. So that means we're subtracting 1 from something else. We're subtracting it from twice the other. So 2y. Okay, so we can substitute this in for x. So into row 1, we can say instead of x, we're going to x plus y equals 14. But in for x, we have a recipe of 2y minus 1 plus the y equals 14. So 2y and y is 3y minus 1 equals 14. Adding 1, we get 3y equals 15. So y equals 5. And so if 5 plus something gets to 14, x must equal 9. Okay. let's figure out the two systems here for 10. It says John invests twice as much money at 6% as he does at 5%. If his investments earn a total of $680 in 1 year, how much does he have invested at each? So what he's earning is interest. So we're just having to multiply the values. So John invests twice as much money at 6. So if we call X the 6% one and Y the 5% one, it says John invests twice as much money at 6 as he does at 5. So X is twice as much as Y. And their interest is 680. So that means 0.06 times X plus 0.05 times Y is the interest. This is the value equation here. But we know that X is the same as 2Y, so we can put that in. So 0.06 times 2Y plus 0.05Y equals 680. So this is 0.12Y plus 0.05Y equals 680. So those add to make 0.17Y equals 680. And so we are going to divide. Go back to Desmos momentarily. And we can put in 680 divided by 0.17, and we get 4,000. So it looks like this is 4,000. And X is equal to 2Y. So we must have invested 8,000 into X. And that's what we did. Okay. You can see the answers here in my book, but I want you to read the problems. For number 11, it says there were 750 tickets sold for a basketball game for a total of $1,090. If adult tickets were $2 and children's tickets were $1, how many of each kind were sold? Okay, so our number 11, the count equation means that we have, I'm going to say A plus C for adult and children. There were 750 tickets total. And the value equation is the adult tickets were $2 times the adult plus $1 times the children, and it brought in $1,090. So I like substitution better, so I'm going to subtract C and say that A equals 750 minus C, because that's an easy one to do. So I can substitute that in for A. Into 2 times 750 minus C plus C equals 1090. And then we're going to distribute. So we have 1,500 minus 2C plus C equals 1090. So 1,500 minus C equals 1090. And we're solving for C, so I'm going to subtract 1,500. We get a negative C equals a negative 410. And we can't have negative children, so we have to divide through by a negative. So C equals 410 children tickets. Okay, so that means 750 minus 410 is 340 adult tickets. We did it. Now 12 says how much. So these can be done in Desmos too. So let me just show you here. Let's just change this up. Okay, so number 12, let's write out the equations and then we'll find these solutions in Desmos. So number 12 says how much 30% alcohol solution and 70% alcohol solution must be mixed to get 16 gallons of 60%. So we want our count or our total gallons to be 16. So we're going to say x plus y equals 16. We know that. And then we know that one of them is 30%, so 0.3 times x. The other one is 70%. And our final solution is 60%, so we have to multiply 0.6 times the 16. And then I'm going to use substitution. So I'm going to say x equals 16 minus y. So I'm going to put that in for x. So 0.3 times x is 16 minus y plus 0.7y equals 0.6 times 16 is 9.6. Then we have to distribute, I'm just going to zoom in for you. We have to distribute this 0.3, remember that's a 0.3, to both terms on the inside. So 0.3 times 16 minus 0.3 times y plus, that's 0.7y equals 9.6. So 0.3 times 16 is 4.8. And then minus 0.3 and plus 0.7 is a plus 0.4y equals 9.6. Oh, I was going to do this in Desmos, but here we just did it by hand. Oh, well. Subtracting 4.8, we get 0.4y equals 4.8. And if we divide 4.8 divided by 0.4, we're going to move the decimal over on both, and we should get 12. So 12 gallons of y. Y is the 70%. And so that means 16 minus y. So that means 4 gallons at the 30%. Okay. Let's look at 13. Okay, 13. So upstream and downstream, these are always a little tricky. So 13 says a boat can travel 20 miles downstream in 2 hours. The same boat can travel 18 miles upstream in 3 hours. What is the speed of the boat in still water, and what is the speed of the boat and what is the speed of the current? So downstream, so we have to remember that distance equals rate times time. So this 20 miles is equal to the speed of the boat. So we have downstream. So the speed of the boat is Downstream. So downstream means they're going with the current. So they've got the speed plus the current times 2 hours. And then they can travel 18 miles upstream. So this downstream, the speed is getting faster with the current. So upstream, the speed is getting slower with the current, and that takes them more time, 3 hours. So what is the speed of the boat, S, and then the current? So speed and the current is what we're looking for. So let's go in and type these as X and Y. So I'm going to go to Desmos. Okay. So I'm going to go up here and turn off these. And then I'm just going to make a little note that this is number 13. Okay. So we have 20 equals X plus Y, times 2. And 18 equals S minus, or X, we're going to call it X minus Y times 3. And then we're going to go up to where they cross. So they cross at X equals 8 and 2. So X is the speed and Y is the current. So the speed is 8 miles per hour and the current is 2 miles per hour. Take you back to my paper so we can see how I type that. So the speed is 8 miles per hour and the current is 2. Okay, our last problem for the chapter 4 review says, it says a collection of nickels, dimes, and quarters consists of 15 coins. So we've got 3 types, N, D, and Q. There's 15 of them with a total of $1.10. If the number of nickels is 1 less than 4 times the number of dimes, how many of each coin are contained in the collection? Okay. So okay, so let's write down what we know. We know that let's call them nickels plus dimes plus quarters equals 15 of them, right? And we also know that 5 cents times the nickels plus 10 cents times the dimes plus 25 cents times the quarters equals $1.10. So there can't be too many quarters because we have to have 15 coins total. Okay. And then something else we know on the side is that if the number of nickels N is 1 less than, so 1 less than 4 times the dimes. Okay, so that's good. We know that. So we can rewrite row 1 with N plus, we know, N is 4D, plus 1, plus D plus Q equals 15. So when we combine the D's, we've got 5D plus Q plus 1 equals 15, or 5D plus Q equals 14 when we subtract 1. So there's our row 4. And then we can put what we know about nickels is 4 dimes 10 minus 1 into the second row. This is row 1 and row 2. In row 2, 0.05 times 4D minus 1 plus 10.10D plus 2.5Q equals $1.10. So this is 0.05 times 4 is 0.2D minus 0.05 plus 0.10D plus 0.25Q equals $1.10. So let's get this. So row 5 is really the 0.2D and 0.3. So 0.3D plus 0.25Q minus 0.05 equals $1.10. So when we add the 0.05 to both sides, we get our final row 5 over here. I'm going to put this in the Desmos. We get 0.3 D's plus 0.25 Q's equals, by adding 0.05 to both sides, $1.15. So we can put row 4 and row 5 into Desmos here. Let's just make a note of this. This is number 14. Okay, so we have, we're going to call dimes x, so 5x plus quarters, we'll call y. Oh, yep, equals 14. And then we have 0.3x plus 0.25, y equals 1.15. I'm going to turn these other ones off here. Okay, so 5x plus y equals 14, 0.3x plus 0.25. Okay, so let's see, where do they equal? So it looks like x plus y equals 1.3. X plus 0.25 equals okay. Let me go back and look at this. I'm going to pause for just a moment. I found where I made a mistake right here. So we said nickels are 4 dimes minus 1, but I put plus 1 right here. So this should have been a minus 1. And so that should be a minus 1. So then we added 1 that should be really equal to 16. So that's the only thing I have to change. Thank goodness. Is it's 5 dimes plus cube orders equals 16. Hopefully that's what fixes it here for this to make sense. And that looks like that may be better. And oh, 3 and 1. So 3 dimes and 1 quarter. 3 dimes, 1 quarter. So there must be 11 nickels. I'll put that right here. So 15 minus 3 minus 1 means there should be 11 nickels. And I'm going to go back to the paper so you can see. So there must be 11 nickels to equal 15 coins. Woo! So I hope that helped on the review for chapter 4.